Yes, hello Arnav, Iram. Is this audible?
Yes, ma'am.
Alright. So in the last class we had completed if you have to find out the constant's value using dimension formula, how to find it. So we had done few questions on it, and this table we had completed. We had done 24 quantities approximately, and we had seen how to find out the dimensional formula of quantities. So see, one of the applications of dimensional formula, one is this, how to find out the unknown quantity. The second one is derivation of a formula. Now, if you are given certain quantities, if you know their proportionalities, then using dimensional formula only, you will be able to find out what is the formula. For example, if I say derive the formula of force, derive the formula of centripetal force. Now it will tell you on which quantities is the centripetal force proportional to. So if it depends on mass, velocity, and radius of the path. Now see, how will we find out what is the formula? What we know till now, that we know force. Force is depending on what? It is depending on mass, velocity, and the radius. So force is depending on mass, velocity, and the radius. So remove the proportionality sign using a constant. F is equal to K M V R. Now, we don't know whether it is m to the power 1, v to the power 1, r to the power 1. So what you can do, take any variables like x, y, z, m to the power x, y to the power v to the power y, r to the power z. Because right now we don't know their dimensions. After solving, no, we'll be able to find out what is the dimensions of mass or what are the dimensions of each of them. Right now, what are we aware of? We only know that force is dependent on mass, velocity, and radius. So what you should do, first write down all the dependencies, since we are not aware of the dimensions part. For example, if I tell you area's formula is L square, so you are sure about it that the dimension of length area is what? L square. Dimension becomes 2. The power becomes 2. In case of force here, this formula, we don't know. We only know the dimensions of force, but we don't know the formula, how force, mass, velocity, and radius are related to each other. So now what we can do, we have this with us, f is equal to k, m to the power x, v to the power y, and r to the power z. You know the dimension of force, you know the dimensions of mass, you know the dimensions of velocity, and you know the dimensions of radius. So first start writing down. This is the second step to find it out. So force is what? And this is a constant. And remember, constants are always dimensionless. So don't worry about this k that I have written. You can write down with the help of the proportionality sign only. Otherwise, just write a k. Even if you add a k, that will be sufficient. Or if you want, you can keep on writing the proportionality sign. It's just that we are forming an equation. An equation will be having that equal to sign. That's why we are just putting equal to k. Whenever in mathematics you have to remove the proportionality sign, remove the proportionality sign by adding equal to with a constant k. So see, dimensional formula of force is what? Yes, what is the dimensional formula of force? Both of you write me quickly in the chat box. Dimensional formula of force. Yes, Arnav, what is the dimensional formula of force?
Just a second, ma'am. My computer
Okay.
started lagging.
Take a minute, just send me what is the dimensional formula of force. Take the help of mass multiplied by acceleration. See, force is what? Mass multiplied by acceleration. Acceleration is velocity by time. Means L by T is for velocity. So it becomes L by T square. That is LT to the power minus 2. So mass multiplied by acceleration, this is mLT to the power minus 2. This is your force. Are you able to recall it now?
Ma'am, I had sent it in the chat.
No, and now just check once again.
It went to the host. Okay.
Okay. So you wrote this one only?
Yes, ma'am.
All right. Okay, good. So both of you have written. Now, constant, there's no need of writing it. Just we want to remove the proportionality sign, so that's why I've written it. Now, mass, we know what dimension formula of mass is m only. So it will be m. Now, we don't know what is the power of m, so write it as x. Now, second quantity is velocity. Velocity is L t to the power minus 1. Because velocity is what? Distance by time. Yeah, means length divided by time. Now, what is the power of this whole bracket? Y. And then you have radius. Radius, we always write it in terms of length only. So this becomes length to the power z. We know up till here. Now, what? Just multiply all the power, distribute all the power to each quantity. For example, you have mLt to the power minus 2 over here. This was k. Now power of m becomes to the power x. L to the power y, t to the power minus y. What did we do? We just distributed, multiplied it with the power. Why? Because if I'm writing L to the power L multiplied by t to the power minus 1 whole to the power y, it means it is power of y is the power of L as well as y is the power of t to the power minus 1. So we are just putting and dividing each power of it. Y was the power of complete velocity. Now we have expanded velocity. We have expanded velocity in terms of length and time. So what is the power of length? What is the power of time that we are receiving? Since we don't know the definite value, we have taken it and assumed it as y. So we'll multiply it by L to the power 1. Now 1 multiplied by y gives you L to the power y. Similarly, t to the power minus 1 was there. Now it becomes t to the power minus y. What is left? L to the power z. What all powers are there? Just multiply to each of them. This is your answer. Now, what we have to do in order to find out the values of x, y, and z, we have to compare it with the known quantity. What is the known quantity to you? Only force? This you are sure that the power of mass is 1 over here. Here you are sure that the power of length is 1. Here you are completely sure that the power of time is to the power minus 2. But here we are not aware of. So what all quantities are here? Just equate them. For example, mass is what? Mass is m to the power 1 over here. And what is mass from here? It is m to the power x. So it means if we are equating it, and this is a standardized general formula, it means both the quantities are balancing, both the quantities are equal. That's why we are equating it. So it means m to the power 1 is equal to m to the power x. So x will be equal to 1 from here. Now let's come to length. What about length? Regarding length, see, here we have L to the power 1. Now here it is equal to L to the power y plus this z as well. If you combine L to the power y with this L to the power z, that becomes y plus z only. This y of L, this z of L. So it means y plus z is equal to 1. Here it says that y plus z, this is equal to 1. Now, the last one. This is t to the power minus 2. t to the power minus 2. And what is time from here? This is only t to the power minus y. It means equate both the dimensions or both the powers. So minus y becomes equals to minus 2. Minus minus sign gets cancelled. Y is equal to 2. Now you have the value of x as 1, value of y as 2. If y is 2, so it means z will be what? It will be 1 minus 2, that becomes minus 1. So now you have values of x, y, z, all three of them. Put it in the formula that we assumed in the beginning. What was the formula we assumed? F is equal to k m v r, power was x, power was y, power of z. Now you know the powers. K m to the power x is 1, so this will be 1. Y is 2, so it becomes v square. R is what? R is minus 1. What you can do? You can put R in the denominator to make the power positive. This becomes mv squared divided by R. And this is only the formula of your centripetal force that you get. Clear how to derive any formula? Do one thing, note it down. If you're not able to understand any step, just ask me. We'll do one more example, so that will ease your understanding. And if you're still not able to understand, let me know. I'll repeat it again. So from here, start right. This is the second application. One was how to calculate the dimensional formula. Now using the dimensional formula, how to find out the derivation of any formula. Done?
Just a second, ma'am.
Completed now?
Yes, ma'am.
Yes, ma'am.
Okay. Let's do one more example, then I'll give you a question. You both will try on your own. So let me first, we'll do one more question together. Derive formula of time period of a pendulum. Of a pendulum. Now, the factors on which the time period depends. If it depends on length of the pendulum and acceleration due to gravity. Now see, again, the steps remain the same. So how will we do it? You have to derive the formula of time period. It means time period. This is proportional to what? Firstly, it is proportional to length of the pendulum. Means let us write it as L. L represents the length of the pendulum. And acceleration due to gravity. In your gravitation chapter, in your term 1 only. First term NCRT part 1 book only, you have this chapter gravitation. There you will be studying acceleration due to gravity in detail. So this is represented through G, acceleration due to gravity, whose value is fixed, 9.8 meter per second square. Now, time period here depends on what? Length of the pendulum and acceleration due to gravity. Remove the proportionality sign, add a random constant, Lg. Now, powers of Lg, take it as x, take the power of g as y. Since there is not a third physical quantity given, so no need to take z. So, time depends on it. Now, dimensional formula of time is what? It's t only, is equal to k. Dimensional formula of length is L. Dimensional formula of acceleration due to gravity is same as that of acceleration. L multiplied by t to the power minus 2. L t to the power minus 2. Whatever is the acceleration's formula, no, your dimension formula of acceleration, it is the same for acceleration due to gravity. So this is Lt to the power minus 2. Now the whole power is x and the whole power on this bracket is y. But we still don't know what are the powers on individual, either on t or either on L. So multiply. T is what? T is k, L to the power x, multiply this and multiply here. So it becomes L to the power y, t to the power minus, this is minus 2y. Reason, minus 2 is getting multiplied by y. So this becomes t to the power minus 2y. Now let's equate. Here mass is 0. Here also we don't have any mass. So it means m is 0. So m will be 0 here only. Now ml. What is the dimensional formula, or what are the dimensions of length in case of the left hand side? What power should I write for L?
L to the power x plus y.
L to the power x plus y for right hand side. For the left hand side, Arnav?
Or left hand side will be 0.
It will be 0. So this will be L to the power 0 because there is no length. We have only time period over here. And this is, as rightly said by you, it is x plus y. All right. Now the third one, time we have t to the power 1. And this is equal to t to the power minus 2y. This much you have. Now let's equate. Mass is 0, so let's not even mention mass. There's no requirement of mass. Length is what? It means x plus y is equal to the power of length. This is 0. And from here you have minus 2y is equal to what? The power of time as 1. So y is equal to what? Y is minus half. If y becomes minus half, so x becomes plus half. These are your dimensions of x and y. Now look at the formula. You have the formula as t is equal to k, L to the power x, g to the power y. Put all the formulas that you're getting. This is k, L to the power half, g to the power minus half. So this is your dimensional formula. What you can do to make the power positive, put the g in the denominator back. This is L to the power half, g to the power half. See, whenever any quantity is having the power half, it means it is under bracket, means under root of it. Or whenever under root is written, it means the power is half, vice versa, both are possible. So here, if you have the power as half, it means, see, till here your answer is completed. But we can extend it. Time will be what? K under root L by G. Reason, L to the power half can be written as under root L and G to the power half can be written as under root G. So this is your final formula. And this is also the time period of a pendulum. The constant just varies. For example, in case of pendulum, you have the constant as 2 pi. So time period becomes 2 pi under root L by G. That you'll be studying in oscillations, the last chapters of your 11th. So right now you just write it as k. You don't need to remember all the constant values. It's just that you should be able to determine all the quantities and the dimensional formula. So note down this, then this one part I'm giving it to you. That you both will try on your own. First note it down, then I'll give you. And you're still having any doubts, just ask me.
Ma'am, can you go up a little? Thank you, ma'am.
Ma'am? Ma'am?
Yes, Aram.
Ma'am, can you explain how did we get x is equals to 1 by 2?
Y is equal to minus half. So we've just put it in over here. If y is minus half will go on the right hand side, so it becomes plus half.
Okay.
Done, ma'am.
See, you have to do it similarly the way we have done it, both the questions we have done. So if you get such equations where, like Aram, you were also asking me, if you get such equations, just put it like x is equal to what? Minus half 0. So if x is minus half is transported on the right hand side, it becomes what? Plus half. So if you're not able to orally do it, then put the values. All right. So similarly, you have to do this question. Now we have done all these quantities together. We have done what is the dimensional formula of speed. See, for speed of light or speed of any object, speed will, the formula, dimensional formula remains same. So it will be speed, and then the gravitational constant we have done, and Planck's constant also we have done. So look into your table and then start doing it in the same manner. Take L is directly proportional to C is the speed of light, G is the gravitational constant, and H is the Planck's constant. So quickly tell me, what are the values of X, Y, and Z coming? Don't derive it again for gravitational constant and Planck's constant. Just look into the table that we have done. No, we had done 24 quantities. So there we have already discussed gravitational constant and Planck's constant. So quickly tell me, what are the values of X, Y, Z coming?
Ma'am, x is 1 by 2, y is minus 1 by 2, and z is 1 by 2.
X is what?
1 by 2,
And Y?
minus 1 by 2,
And Z?
1 by 2.
See, Z is correct. For Planck's constant, Z is correct. Just check for Y and X. There must be some error in your calculation. Just check. Aram, where have you reached?
Just a moment, ma'am. I'm doing.
Okay, one more minute. Till the time Arnav, you check your mistake. Z is correct. Z will be half.
Ma'am, is x minus 3 by 2?
X is coming minus 3 by 2. And what about y?
1 by 2.
1 by 2. Now it's correct. Now let's discuss it. It's correct. Good enough. So you have derived the formula. So write it completely. Try to write the formula completely. Put all the values of x, y, and z. You have derived it correctly. Now let us just discuss it. See, L is proportional to C, G, and H. See, in your examination, you won't be given values, dimension formula of gravitational constant, Planck's constant. So that's why I've made you write that table. Even if you forget, just with the help of the formula, whatever way we had done, remember that table, because from that table only all your questions will be solved. See, the question will provide you all the values on which L is dependent on, but it won't give you the dimensional formula of the rest. So in your examination, if this question comes, then your gravitational constants value and Planck's constants value, all these dimensional formula, you have to write it on your own. Now, let's remove the proportionality sign, add a constant. L is equal to K, C to the power X, G to the power Y, H to the power Z. L is what? L is length, so it will be only L to the power 1, K. C is what? Speed. Speed is LT to the power minus 1, means length by time, whole x. Gravitational constant, this is M to the power minus 1, L to the power 3, and T to the power minus 2. This is your gravitational constant's value 1. And Planck's constant is what? Planck's constant is energy divided by the frequency. So it will be m L squared T to the power minus 1 to the power Z. This will be your Planck's constant. Now multiply all the terms. L to the power 1 is what? This is K. Multiply by each of them. This becomes L to the power X, T to the power minus X. Multiply each of them in this manner. Y with each of them. So this becomes M to the power minus Y, L to the power 3y, T to the power minus 2y. Multiply each of the terms again. So this becomes M to the power Z, L to the power 2z, and this becomes T to the power minus Z. Now we just have to equate. We know all the dimensions for the left hand side, we know the dimensions for right hand side. First, equating mass. Here mass is 0. What all the masses are present? M to the power minus y plus this z. No other mass is possible. Now ml, L to the power 1 is equal to what? L to the power x plus 3y. Any length left? 2z. So it will be plus 2z. Then you have time, mlt. So t to the power 0 would be here, and time will be what? T to the power minus x. From here it is minus 2y. From here it is minus z. You have resolved all the left hand side's value with the right hand side. Now write the equations. Minus y plus z is equal to what? 0. X plus 3y plus 2z is equal to what? 1. And minus x minus 2y minus z. This is equal to 0. See how many variables you have? You have 3 variables. And for solving 3 variables, minimum number of equations required is also 3. How number of variables and number of equations, both are always same. For example, if you have 2 variables, so even if you have 2 equations, you will be able to solve it. But if you have 3 variables and you have 2 equations, then you won't get the answer ever. So here we are having what? We are having 3 equations and 3 variables. So we can solve this. So let's add these 2 equations and try. If you add both these equations, it will be what? X plus 3y plus 2z. Here you have minus x minus 2y minus z. If you add them, x gets eliminated. This becomes 3y minus 2y. This becomes y. 2z minus z. This becomes plus z. And sum is what? This becomes equals to 1. So now you have reduced form. What are your equations now? Y plus z is equal to 1, and the other equation, this was minus y plus z is equal to 0. Again add both of them. If you add both of them, again y will get cancelled because y minus y will be 0. Z plus z is 2z. This is equal to 1. So z is equal to what? Z is equal to half from here. Now, if you have value of z, you can get value of y. Y is what? This is minus y plus z is 0. So minus y plus half is 0. So y will be equal to what? Y will be equal to minus y will be equal to minus half. Y will be equal to half. So y is also half. Now, y, z are known. You can get the value of x. Put it in any equation. Put it in the last equation. It is minus x minus 2y. Y is what? Half. Minus z. Z is also half. So 2 gets cancelled. This is equal to what? 0. So minus x minus 1 minus 1 by 2 is 0. If you solve minus 1 by 2, this is what? This becomes minus 2 minus 1 by 2. That is minus x minus 3 by 2 is 0. So x becomes equals to positive 3 by. These are the values that you're getting. Now put it in the main equation that you had. L was equal to k c to the power x, means c to the power minus 3 by 2. Then you had gravitational constant y to the power half, and you had Planck's constant to the power half. This is your final formula. Clear? Aram, is it clear to you? Because Arnav got the answer. What about you, Aram? Is it clear?
Yes, ma'am. Yes.
If you're not able to understand any of these steps, these cancellation and addition, just ask me. Alright, so first note it down, all anyone who has not written it. Question you must have. Yes, written.
Yes, ma'am.
All right. So
Yes, ma'am.
I think now you will be able to solve if any formula is given. Let's discuss the last application of dimensional analysis. So from the next class, you have your next class on Monday. So from the next class, we'll cover the portion of error analysis that will be used in your practical as well. So dimensional analysis, the last application is conversion of units. Now, conversion of units, for example, if I say how to convert 1 kg into grams, you will say you'll multiply it by 1000 because 1 kg is equal to what? It is equal to 1000 grams. So you remember this, that 1 kg is equal to 1000 grams. This is set in your mind. But if I ask you 1 Newton, Newton is the SI unit, dyne is the CGS unit. If I ask you convert Newton into dyne, so how will you convert? Either you remember it, and if not, then what's the method? So conversion of units can be calculated using dimensional formula. Understand how? Two examples I'll discuss with you, then one I'll give you. See, N1, N2, or let's do it with the help of an example. With the help of an example, let's take convert 1 Newton into dyne. So see, you have to convert 1 Newton into 1 dyne. This is, and Newton is what? Newton, remember, Newton is the SI unit of force. SI unit of force is Newton. Whereas the CGS unit, this is dyne. So if you have to make out the conversion, you have to remember at the end, ultimately, few conversions you have to remember. The way you remember that 1 meter is equal to 100 centimeters or 1 kg is equal to 1000 grams, the way you remember this. So similarly, you have to remember all these. But if you're not aware of what is the conversion, what is the relation between them, then how to identify? See, write the magnitude, means this is the magnitude, 1 is the magnitude as N1. Then whatever unit is there, this is U1 equal to 1 dyne. So from here, the magnitude number is what? N2. Unit is what? U2. This is the standard way of calculation. Now, how do we write it? Best way, Newton is the SI unit of what? Is the SI unit of force. So write the dimensional formula of force instead of unit. Number here is 1. Why? Because this is 1. N1 here is 1. And dimensional formula for Newton. Instead of Newton, let's write the dimensional formula. So this is LT, mLT to the power minus 2. Mass into acceleration. This is U1. Similarly, N2. And since dyne is also the CGS unit of force only, the dimensional formula will be this. So we have it. Now, if you have to know what is M, okay, let's name it as M1, L1, T1, and we name these as 2. So as to differentiate between the mass of this SI unit and mass of the CGS unit, all the systems get differentiated. That's why we have written 1 and 2. Now N2 is what? We don't know, na? 1 Newton is equal to how much dyne? We are not aware of. We have to calculate this number, no? 1 Newton is equal to 5 dyne, 1 Newton is equal to 100 dyne, 1 Newton is equal to 3 dyne. What is that number? We have to find out N2 only. So N1 is this, U1 is this, N2 we don't know, U2 is this. SI unit with the magnitude, CGS unit with the magnitude. So we are calculating N2. From here, N2 will be what? N2 will be M1 L1 T to the power minus 2. Divide all the like terms together. This becomes L2 divided by T to the power minus 2. This is mass, this is length, and this is your time, 1 and 2. This is what we have to calculate. N2 is unknown to us. Rest of the things we know. The magnitude was 1, so even if you multiply, you get this back. Now, how to write this? M1 is what? Mass 1, Newton. It is in kg, so it will be 1 kg. M2 is what? For dyne. It means it is in CGS unit. It means it will be 1 gram. Alright. To the power 1, since the whole unit is power is 1. Length. For Newton side, L1. SI unit is what? Of length. It is meter, so it will be 1 meter. Divided by, what is the CGS unit of length? CGS unit of length is 1 centimeter to the power 1. And it will be 1 second in CGS and 1 second in SI to the power minus 2. First tell me, is this clear? What have we done till now? Any doubts till now? Yes, Aram, Arnav?
No, ma'am.
No, ma'am.
Alright. Now see, now this conversion you remember, no? Kg into grams, meters into centimeters. This is easy for you. So now write it, convert it. This becomes what? 1000 grams divided by 1 gram to the power 1. 1 meter. This is equal to what? This is equal to 100 centimeters. We are just making it in terms of, this will be equal to 100 centimeters divided by 1 centimeter to the power half. So that is gram gets cancelled, centimeter gets cancelled, and 1 second is getting cancelled automatically. From here also you can see 1 second is getting cancelled. So what are you left with? N2 is equal to what? 1000 multiplied by 100. Rest all the units have been cancelled. It means N2 is what? 10 to the power 5. Now see what was missing. N1 is 1, U1 is Newton. 1 Newton is equal to dash dynes. So 10 to the power 5 dynes. This is your final answer. Here, note it down. We'll do one more. We'll do one more so it becomes clear to you. Then I'll give you a question. If you're having any doubts in the calculation, in any step, just ask me. Because this is a very basic chapter and this should be scoring. This is a very scoring chapter for all of you. So you should not commit errors in the calculations of this. Now, the SI unit of energy, this is joules, and the CGS unit of energy is erg. Now, how much 1 joule is equal to 1 erg, or how much 1 erg is equal to 1 joule? That relation we have to now first identify. Now, you are not provided 1 joule. So, N1 is 10 right now, whatever is the magnitude. What is the formula I've told you? N1U1 is equal to N2U2. N1 is the magnitude of the quantity in the first unit. So here it is 10 multiplied. Joules is the SI unit. U1 done. N2, we don't know. We are calculating N2. U2, this is erg. Now, joules and erg, both of them are SI units of energy. That's why in the starting only we have written that in that table SI units and CGS unit as well. Now let's write it for energy. For energy, it is what? ml square t to the power minus 2. This is for energy, the dimension formula. So this is 111 for the first unit, and 2 multiplied by ml square t to the power minus 2. This is for the second unit. 2, 2, 2. We have to find out n2. n2 will be equal to 10. This whole term getting divided by this term. So mass getting divided by mass, and the whole power is 1. Since mass, both the masses are having the power 1. Length, L1 by L2, both the lengths are having the power 2. And T1 by T2 time are having the power minus 2. Now, first unit, 1 unit is the SI unit. So we know what is the SI unit of mass. So I'll write 1 kg. And M2 was for CGS unit. From erg I have taken, so it will be 1 gram to the power 1. For length, the SI unit in terms of Newton, because Newton is the SI unit. So SI unit is 1 meters. CGS unit is centimeters to the power 2. Time is seconds in both the cases to the power minus 2. Now let's convert. 1 kg can be written as 1000 grams. So N2 will be equal to 10 multiplied by 1000 grams divided by 1 gram to the power 1. 100 centimeters divided by 1 centimeters to the power 2. And seconds will get cancelled over here. So gram gets cancelled, centimeter gets cancelled. See what is left. 10 multiplied by 1000 multiplied by square of 100. That is your 10,000. Square of 100 we are taking. So how many zeros are there? 4, 5, 6, 7, 8. So N2 is coming what? N2 is coming 10 to the power 8. It means here, this was 10 to the power 8. It means 10 joules is equal to what? 10 to the power 8 erg. Clear? Both of you, Aram? Clear, Aram?
Yes, ma'am.
Arnav, what about you? Clear to you?
Yes, ma'am.
All right. So note down this. Then now I'm giving you a question that you both will try on your own. First, note this.
Ma'am, can you go up?
Here, this is fine, Arnav? Or a bit more?
No, it's not.
Okay.
Yes, ma'am, you can go down.
See what this question says. It says you have to convert power of 60 joules per minute. See, 60 joules per minute is not the SI unit. Joules per second is the SI unit of power. So first convert power into SI unit, then only start the question. Power is what? 60 joules for 1 minute, means per minute. So it will be 60 joules by 60 seconds. 1 minute is what? 1 minute is equal to 60 seconds. So that's why 1 minute, you can write it as 60 seconds. It means power is what? 1 joules per second. Now you have the power. You have to convert it into a system where mass is 100 grams, length is 10 millimeters, and time is in minutes. As in, you know this formula, N1 U1 U1. This N1 U1 is equal to N2 U2. 1 joules per second is the SI unit, N2 you don't know, and this is the new unit of it. This is how we write new units and old units. This is 1 multiplied by energies is ml square t to the power minus 2. Now this is power. This is power energy per unit time. So this will be t to the power minus 3. It is energy per unit time. No, energy is this. So for time, one more time will get added, second will get added, is equal to N2, and this is ml square t to the power minus 3. This is 1, 1, 1. This is in system 2 you have. Now M1 is what? M1 is given to you. This M1, this is given to you 1 kg because it is in the CGS unit. So it is 1 kg only. Now L1 will be what? This will be 1 meter and T1 will be 1 seconds. SI unit is fixed. But in the system of new units, what is M2 given? This is given 100 gram. L2 is given what? L2 is given 10 millimeters. And time is given 1 minute. Now using this, now put it over here and then convert 1 kg into 1000 grams and then cancel gram and see what is the value of N2 coming. Try this question yourself. Hint, I have given it to you. This is the question. This is a hint of it. Tell me what is the value of N2 coming. N2. So Aram, we are waiting for your answer. Arnav has submitted his answer. All right, Aram, are you trying? Okay,
Ma'am,
Aram, yes, Aram has also submitted. Okay, now let's discuss it. Let's discuss it. I think there's slight error in your answer, Aram. Very slight error in the powers only. 10 to the power 6, it would be 10 to the power 8 most probably. Okay, let us calculate it together only. Let's calculate it together and see what is the answer coming. So till here you both know. N2 will be what? This will be M1 by M2 to the power 1. It will be L1 by L2 to the power 2. This will be T1 by T2 to the power minus 3. Okay. M1, this is 1 kg. M2 is not 1 gram this time. This is given to you as 100 grams. It's given 100 grams of what? Yes, 100 grams. It is given 100 grams to the power 1. Now length. This is 1 meter by 10 millimeters whole square. And time is second, but T2 is not second this time. T2 is given as what? T2 is given as 1 minute. T2 is given as 1 minute to the power minus 3. Now first let us convert this, then we'll see the power. This will be 1000 grams. We just have to make it into a common unit so as to get them cancelled. This is by 100 gram to the power 1. 1 meter is there. You can do one thing. 1 meter can be written as, either you can make it as 1 millimeters, or you can do one thing, you can convert 10 millimeters itself into 10 meters. So well, let's convert 1 meters only. If you convert 1 meters only into the SI unit in the millimeters form, it will become easier for us. Since we are writing everything in CGS, let's write it in the unit only. So 1 millimeter, it is 10 to the power minus 3 meters. So 1 meter will be 10 to the power 3. This will be 10 to the power 3 meters. This will be, so it will be 1000 millimeters. See, 1 millimeter is equal to 10 to the power minus 3 meters. 1 millimeter is equal to 10 to the power minus 3 meters. 1000 millimeters divided by 10 millimeters to the power 2. Seconds. 1 minute is equal to 60 seconds. You can write it in this manner. To the power minus 3. Gram gets cancelled. 2 zeros gets cancelled. Millimeter gets cancelled. 1 zero gets cancelled. And here you have 1 second. Seconds get cancelled. So what are we left with? N2, we are left with 10. This is square. So it becomes 10, 100 square becomes 10 to the power 4. And here you have 60 to the power cube. Because it's minus 3, so you can write it as 60. So N2, this will be what? 60's cube is 216,000. Multiplied by, you get it 10 to the power 5. So 678. This becomes 2.16 into 10 to the power 8. This is your answer. All right, Aram. So I think you were getting 2.16 into 10 to the power 6. It would be 10 to the power 8. Just check your calculations once again. Otherwise, you were correct. All right, Aram, clear?
Yes, ma'am.
Okay, one question I'm giving you as homework so that you will try and we'll discuss it in the next class. Last question, then we'll begin with the error analysis portion. So if you have any doubts, you can ask me. Time is 10 meter per second. Time is 10 seconds. Velocity is 10 meter per second. Time is 10 seconds. This is 10 seconds. You have to calculate fundamental unit of length, mass, and time. Okay, Ram. So quickly note this question and let me know when you're done. So just try to find out the answer. We'll discuss it in the next class.
Ma'am, sorry, I was not able to hear your voice. Could you repeat, please?
Yes, Iram, I was saying just note down this question. If fundamental unit of force is 100 Newton, velocity is 10 meter per second, time is 10 seconds. You have to find out the fundamental units of length, mass, and time, whatever in the system it is given. So just note down the question, take the screenshot of the question, then we'll discuss it in the next class. All right?
Okay, ma'am.
Let me know when you're done.
Done, ma'am.
All right, Iram. So yes, Iram, you can leave the meeting. In the next class, we'll continue.
Okay, ma'am.
All right,
Thank
so
you.
try to solve the question. We'll discuss. All right. Okay, laugh. Yes, Ahmed. What's your name? Ahmed Faiz.
Faiz, ma'am.
Faiz. Ahmed Faiz. Okay. So you're from 12th standard, no?
Yes, ma'am.
All right, Ahmed. So see, Ahmed, we had started with this unit of your 12th standard, which is your electrostatic units only. Ahmed, can you tell me which chapter is currently going in your school right now?
Ma'am, we are in this